All right, moving on to 69. Consider Anita's method from 467. Anita took the logs of both sides. Use her method to evaluate log base 3 of 11. So if we start by letting log base 3 of 11 equal x, and then we rewrite using our little circle, 3 to the x equals 11. And then Anita's method was to simply take the common log of both sides and then use that power rule right there. So we have x log 3 equals log 11. To solve for x, we can just divide by the log 3. So x equals log 11 divided by log 3. Now let's go back to the original problem. We wanted to evaluate. There was no solve direction. We used the x as a placeholder for our evaluation. So really, log base 3 of 11 equals the log of 11 divided by the log of 3. Use your steps from part A to write an equivalent expression for log base b of a. This is the change of base formula. So we kind of just discussed that. Log base b of a equals the common log of a divided by the common log of b. So any calculator now, even if we don't have the nice new TI-84 Plus that has the base in it, can do this evaluation. And remember, we're evaluating, not solving. All right, let's take a look. Number 70, solving. Let's use what we learned. And now we are solving, we're not evaluating. Give solution as an exact form, so no decimals. If we have log base 7 and log base 7, we could just set these equal to each other. Subtract them over, get it equal to 0. Factor x minus 5, x minus 3. So x equals 5 or 3. Looks good to me. Let's try the next one. So we've got a plus going on, we've got a minus going on, and we've got it equals. So log base 2 of x cubed times x over 2x. Plus means multiply, minus means subtract, equals 6. Now we can simplify a little bit here. That x can go away with that x, and we can really just call that a 1/2. Now this 2, we could rewrite it in exponential. 2 to the 6th power equals 1/2 x cubed. Getting close. 2 to the 6th power is 64. Divided by 1/2 is 128 equals x cubed. Cube root of 128 equals x. Good. Let's try the next one. Got addition again. So log base 7 of x minus 4, x plus 2 equals 1. Do our circle, 7. And I'm going to do the multiplication inside here right away. X squared minus 2x minus 8 equals 7 to the 1st power. Subtract the 7 over, x squared minus 2x minus 15 equals 0. Factor that, x minus 5, x plus 3, and then x equals 5 or negative 3. Now in this case, we need to check. If I put a negative 3 right there, I get a negative 1. So I have log base 7 of negative 1. And our domain is it has to be greater than 1 and greater than 0 in there. So we'd cross out the negative 3 and it's only x equals 5. Alright, how about our next one? I think we should use a power rule here and subtract this guy over. Actually, if we go natural log notice this. What is this guy right here? E to what power is e to the 5th? So that's actually just a 5. Oh, 5 minus 2 is 3. Divide by the 3. I've got 1. So now I've got this e down here. E to the 1 equals x. X equals e. That's a sweet little problem. And then finally, I always want to get these natural logs by themselves. So I'm going to divide that negative 9 over. Natural log of x plus 1 equals 8/9. Again, natural log means there's an e down there. E to the 8/9, I'm putting it into exponential, equals x plus 1. Subtract the 1 over. E to the 8/9 minus 1 equals x. And that would be the exact form. Done. And finally, got some subtraction going on. Subtraction means divide all of it inside. Equals 10. Got my e here. E to the 10th equals x plus 8 over x minus 4. How are we going to solve this? We can multiply both sides by the x minus 4 to get rid of it down here. And then, got a little math going on here. This is going to be a fun exact value one. X times e to the 10th minus 4e to the 10th equals x plus 8. Let's get all the x's on one side. X e to the 10th minus x equals, keeping this 8 over here, adding this over. All my x's are over here. Now I've got a sweet move of factoring that x out. E to the 10th minus 1 equals 8 plus 4e to the 10th. Divide by e to the 10th minus 1, and I'm left with x. That would be 1. That would be advanced math. Might want to practice some properties there. Do it up.